Yesterday we did common factoring, and there's several different types of factoring. And the hardest part is when you mix them all together and you got to decide which one's which. But we're not there yet. And in fact, our first unit of this course won't really have any factoring. So again, this is just kind of warm up, but it's nice to see it and you can remember how good you are or not so good you are at it, that kind of thing, okay? So simply trinomials, that should say simple trinomials, it doesn't matter, but that's what we call them. We call these simple trinomials. This is a totally different kind of factoring from common factoring. What's the same between all kinds of factoring? It's a hard question. So like the way we common factor, the way we do simple trinomials, the way we do difference of squares, the way we do complex trinomials is all different. But they do all have one thing in common. And you can't use one method on a different type. It won't work. But they do all have something in common. Anybody have any idea? Want to guess? Okay, let me see if I can demonstrate with this. If I wanted to take the number 12, we're just like chatting here. This isn't something you really need to worry too much about. I could break it up a lot of different ways. I could say it's 6 times 2. I could say it's 3 times 4. I could say it's, anything else? Huh? Yeah, 2 times 6 or 4 times 3, absolutely. But either way, if I break up the 6 into 3 times 2 times 2, or I break up the 4, 3 times 2 times 2, look, I get the same thing. That's this thing called prime factorization in mathematics. You probably did a little bit of it in elementary school and talked about it a bit in grade 9 as well. It's called prime factorization. Not something you need to know, but it's taking a number and breaking it up into its factors. Basically, the things that divide into it and the smallest ones. Because I can't break 3 up any further, can I? What, 3 times 1? That doesn't count. What about 2? Can I break it up any further? No. That's what we're doing. We're taking expressions, whether it's common factoring, simple trinomial, we're taking it and breaking it up into the things that multiply back into it. Remember when we did common factoring yesterday and we said how if you were to multiply these back together, you'd get back the thing you started with. Remember we said that? That's true of all factoring. Okay? Okay. Let's take a look at the first one. Actually, before we do that, I'm going to show you one thing. We should have done this before. What if I had something like this? X plus 3, x plus 4. And I wanted to expand it. What would that look like?
X squared plus 4x plus 3x plus 4x.
Plus 3x plus, what's the last one? Not 4x, you said that already. 12, very good. Awesome. Nicely done. I don't think we saw any of those like that yet, did we, in the preview? Plus 12. And this is actually plus 3 times 4, right? And then the next step, I can put the x's together and I get x squared plus 7x plus 12. And this is 3 plus 4, and this is 3 times 4. And that's a really important part of simple trinomial factoring. We notice that pattern that when we have two binomials and we multiply them, every single time when they're in this kind of form, every single time I get two terms that I add together, and then these two numbers that the same two numbers, 3 and 4 and 3 and 4, every single time. Do you believe me? We haven't done a lot of these, so you might not see the pattern, but that's in grade 10 when you learn this, that's what you would have done, I'm sure. Is do a bunch of these and notice the pattern. 3 plus 4, 7, 3 times 4, 12. And then we use that knowledge to work backwards. And so when I look at question A here, what am I looking for? Okay, first thing, my answer when I factor is going to look like this. And it's really important when you're factoring that you know what the answer looks like. Because that won't work itself out. When I expand, my answer appears. When I factor, I need to know what it looks like. So this is a simple trinomial. That's why it's tricky. That's one of the main reasons why it's so tricky. And when you got the different types, you got to know what this type looks like to what that type looks like. So I know it's going to be two binomials, right? Because I recognize the pattern. And I know this is going to be x. You can write this down. And I know this is going to be x. And now I just have to find those two numbers. So does anybody remember? Is this starting to come back at least a little bit? The simple trinomials aren't the hard ones. You were probably all pretty good at simple trinomials. It's a little bit harder when you add in negatives, but not too bad. Complex trinomials, that's the one that some people never quite clicks for them. So, what am I looking for? Two numbers that? Add into, yes. Multiply to 50 and add to 15. So they add to the x term, just like if I go back here and I look, oh yeah, right, because it's 4x and 3x, add to 7x. But 4 times 3 gives me the 12, the constant at the end. So can anybody think of two numbers that add to 15 and multiply to 50? Lots of people do, yeah, Brooke? 5 and 10. So plus 5. And sometimes we have to worry about positives and negatives, but this time we don't. And I could always do a little check, but don't do the check here. No. Whoops. Check below your answer. Do it off to the side. Check. Watch this. X plus 5, x plus 10 is x times x is x squared. X times 10 is 10x. 5 times x is 5x. 5 times 10 is 50. So there's the 5 times 10. And then 10x plus 5x is 15x. And we see that same pattern happening where you have two binomials like this. You expand, the 2x terms add to the middle term, and those two numbers multiply. Same two numbers, 5 and 10, 5 and 10. Jada, did you have your hand up? No? Okay. I thought I saw it like in my peripheral. Okay, let's try another one. What's different about this one? Zach? There is a negative, and that does complicate things a little bit, but not too much. But you do have to be a bit of a detective here. Okay? I know that my answer will still look like this. And because it's a simple trinomial, it'll just be x's out front. So there's a negative. What is that telling me? Both of them? One of them at least? Could both of them be? Very good. How do we know which one's which? Because we have to. So often, or pretty much always, you're not actually going to figure it out by looking at just one of them. I got to look at both. What does the sign of the 12 tell me about this expression? Sarah? So it's positive, so the signs both have to be negative. Or if I only looked at the 12, I know the signs both have to be the same. Either both negative or both positive. Because I'm multiplying a positive and a positive, or a negative and a negative. If the 12, look at the 60, it's negative. So the signs have to be different. A positive and a negative multiply to a negative. So if the signs have to be the same, and this term is negative, the signs are both, we already said this, but go ahead. The signs are both what? Negative. So I could stick those in now if I want to. Were you going to give me the numbers? We're not quite there yet. Hold on. Everybody okay with the signs? You thinking about that? We're going to come back to this later on, so it's not the end of the world if you're stuck on this. But okay, so I'm looking for two numbers that... Somebody else, you answered last time.
Add to -7 and multiply to 12.
Nice. Add to 7 and multiply to 12, or add to -7 in particular, multiply to 12. And we actually saw an example like that already. What are they? Pearson, do you know what they are? 3 and 4. So -3 and -4. And folks, when you do this kind of factoring, you don't have to do a formal check on the side. But if I was you, I would always be like, okay, so -3 plus -4 or -4 is -7, and -3 times -4 is +12. Yeah, like just check your signs, check your answer, make sure that you agree. What do you think? That's right. Doesn't matter. Order doesn't matter. That's the same as like we kind of talked about this before. 3 times 4 or 4 times 3. Multiplication order doesn't matter. Just like adding order doesn't matter. Good question. That always comes up. All right, one more. It's a simple trinomial. By the way, how do I tell it's a simple trinomial? Sure. Very good. So there's no coefficient, or it's a 1, so it's invisible, in front of the x squared term. Remember what I was saying before? What about order? What if I wrote this like -60 plus x squared minus 11x? See how much harder that would be to factor? Because we're just not used to looking at it like that. And you might think like, oh, it's a 60 out front, so this is complex. No, no, no. It's the x squared term that matters. Okay, so this is going to look like this. Sometimes writing that down helps your brain focus on what it's trying to do. So if you're a little bit stuck ever, I would like start kind of writing in some stuff, leaving some blanks that you can fill in, because it helps your brain get on the right path. So I'm looking for so we talked about the signs. So we already talked about the negative. The -60 tells me the signs have to be different. Okay? So I'm actually looking for two numbers that multiply to 60, but then what? They will add to -11, or you might think of it as subtracting to -11. Adding and subtracting is actually kind of the same thing depending on how you look at it. So like it can be complex, and we don't have to worry about that. But so they're gonna have a difference of 11. Geez. Anybody think of anything? What numbers multiply to 60? 2 and 30? No, good. This is like trial and error, right? This is how this works. And actually, when I teach this, there's a little chart that you could draw out, but I don't think probably we need that. So 2 and 30. 3 and 20, that's no good. Sarah, you think you have it? 4 and 15. So I'm just going to put those numbers in. 4 times 15, do you agree that's 60? Use your calculator if you have to. I agree. 15 minus 4, is that 11? They have a difference of 4, yes. So I think we're on the right track. Now we just have to figure out which one is negative and which one's positive. Brooke, what do you think? How do you know? Nice. Because the bigger number will have the same sign as the 11, as the middle term, right? Because the bigger number wins in that battle of positives and negatives. And you can always do a check to make sure that it works. Any questions on that? No? All right. We're going to do a couple more. They're going to get trickier. Those simple trinomials are the ones I really want you to focus on. But you know what? Let's just give this a try and see what happens. When we come back to factoring later, we'll do a more thorough review of how to do this, or we'll look it over again. What's different about this question other than it's not factoring? Anybody notice? You have two variables. There's a y in it as well. So let's expand and see what happens. Yep. X times x is x squared. X times 2y, we did this kind of stuff before, so that's 2xy. 3y times x is 3xy. We usually write the variables in alphabetical order, again, just because it's easier to recognize and easier to read. It's more consistent, but you don't have to. 3y times 2y is 6y squared. So I've got something very similar to the example we saw before, where I've got this x squared term out front. I've got two terms in the middle that are the same. And I've got this last term. But the last term has a y squared added onto it, as opposed to just being a number, like those other questions we were just looking at. Following me here? Yeah? Any questions about that? Why did we just look at this question? Because what would happen if I had to factor something like that? I'm going to tell you a secret. This is not the kind of factoring you really have to do ever. This is just like a made-up math class question where, not ever, but like for us, you know what I mean? Made-up math class question that's just to kind of expand our thinking a little bit, push our algebra skills a little bit, frustrate you just that little bit more to push you over the edge so you quit doing your homework maybe sometimes, right? So it's not like, don't get stressed if these are the ones that you find harder. It won't be that big a deal.
Do you just do this and you find the common result and only one side of the mathematics?
Yeah, that's exactly right. I'm still just recognizing the pattern that there's an xy in the middle and a y squared over there. So it's going to be like the one we just saw. What if it was like xyz in the middle? Oh, then you can't factor it. You can't add other junk. That doesn't make any sense. Okay? So this is just a special pattern that we can actually do. So I'm looking for two numbers that this has the same the positive, so same sign. So two numbers that add to 7, multiply to 12, and they're both negative. What are those two numbers? We already did this question. Yeah, so x minus 3 and x minus 4. But then we realize it's exactly like this question we did over here, right? This B. And you can go back and compare those two and see why they're similar, but how they're different as well. And I go back and I say, but if I expanded this the way it is right now, it wouldn't give me back the original line. Correct? So what's missing? And sometimes you just kind of fudge it. You're just kind of like, I got to stick a y in there somewhere to make this work. And again, you do a sort of check maybe in your head to just see. Are we good? We're going to keep trucking here. We got some more easy ones, really easy ones. And then we might even do, depending on how quickly we get through this one, we might even do a couple of hard ones. We'll see. What are we looking at here? It is a difference of squares. How do you recognize that? Remember what I said at the beginning of the class? Factoring is all about recognizing the type of question you're looking at and factoring it that way. So if you're common factoring, that's a different thing. It's very different from simple trinomial factoring. We just saw that. How do you recognize that this is a difference of squares? Zach, how did you? There's only two terms. That's one of the things. What else? Yeah, they're both squared. Both parts are perfect squares. So x squared and 25 is a perfect square. You know what I mean by that? You know what a perfect square is? Yeah? Like 1, 4, 9, 16, 25, 36, 49. If you square 1, square 2, square 3, square 4, square 5, 5 squared is 25, so 25 is a perfect square. Get that? Okay. And what's the third thing you need, third piece of criteria you need for it to be a difference of squares?
Negative sign?
Yeah, they're subtracting. There's no sum of squares. Can't factor a sum of squares. So what is the trick? Again, this one's easy. It's actually usually everybody's favorite because it's so easy. Difference of squares is the type of factoring this is called. So I take the square root of the first term, which is just x, and I put it there. I take the square root of the second term, which is 5, and I put it here. And what do I put between them? Anybody remember that? That's the trick, is one's positive and one's negative. Doesn't matter the order, just like before, but that's how you do a difference of squares. Try the next one. All right, what's the answer to this one? Can somebody just give me the whole answer? Somebody else? Anybody else? Madison, do you have it? Give it to me.
X plus 3, X minus 1.
How many people got that? Yeah, see, these are super easy. Oh, these ones are easy too, but let's do it. What are we looking at here? We're looking at 4 questions that are all different types, so we've mixed them together, so you have to determine what type you're looking at. So I'm going to give you a few minutes to try each of these, but if you don't get them, that's okay, because we're still working on this, but let's see what you come up with. Okay, let's take a look at these together. A lot of people were on the right track with the first one. You as far as I can tell, everybody immediately thought the first one was a simple trinomial. In fact, before we factor any of them, let's talk about all four and just compare them and see which type they are. So this is a simple trinomial. How do you know? How did you know that it was a simple trinomial? So there's three terms, which is what a trinomial is. So that's a pretty key idea. Remember we said a difference of squares has two terms only, so it can't be a difference of squares. Very good. And there's this thing, we haven't really talked about this yet, but there's this thing that somebody else said the other day, you always common factor first. But there is no, because sometimes you can common factor and do another type, right? There's no common factor. We haven't got to that yet. We haven't started mixing that up. So this is a simple trinomial. Very good. What about C? What type is it? And again, it meets the three criteria. There's two terms. They're both perfect squares, and there's a minus sign between them. What about D? Eunice, what do you think it is? Difference of squares again for the exact same reason. Two terms, both perfect squares, minus sign between them. What about B? You don't, which means it's not a difference of squares. Yeah, it's what we did yesterday. It's just a common factor. B is a common factor, and the reason is t squared minus 4 would work. T squared minus 4t? No. Okay, let's see that when we get there. Let's do this one first. So this is, and this one's really interesting. So on that note, let's forget about that for a minute. Put it aside. We'll come right back to it. This one was tricky. Don't write this down. I saw a lot of people do this. Like a lot of people. So if you did it, you were not the only one. You did this and this. Why? Because 1 times 6 is 6, and 1 minus 6 is negative 5. Very nice. Why is this wrong? Good? You're telling me they both have to be negative. How do you know that? Because of this positive, they have to have the same sign. Both negative. So that's negative 7. This is a tricky question because it has this other answer that like almost works. And it would work if that sign right there was negative. Then it would work. But that sign is not negative. So these numbers are wrong. So I'm looking for the same sign. They're both negative. And I'm looking for two numbers that actually add to 6 and multiply, or add to 5, sorry, multiply to 6. What are they? Yeah, good. 2 and 3, and both negative. Very nice. Let's get these other ones out of the way. Somebody give me the answer to this one. Zach?
9.
Good. So W plus 9 and W minus 9. See how we all even know, like, we all know what he meant. You're just looking for that number. It was 9, so we know how to write it. You do have to know how to write it, obviously. And the last one, somebody else. And I can even go like this, plus, minus. Bethany, did you get this one? 4 is the number we're looking for. Whoops. How could if I didn't know it, how could I figure it out? Square root of 4 on my calculator. Just punch that in. Okay, let's go to B. This was the trickier one. How do I know it's common factor? Remember what we said, you always look for common factors first. Where's the common factor that I see here? The t. This has a t in it, and this has a t in it. So I go t, bracket, bracket. And that's it. No number. I can't pull a number out or anything like that, but t is enough. What's left inside the bracket?
T minus 4.
Nice. So t squared, I pulled 1 t out, I'm left with 1. And I'm left with the minus 4. And I had 1 t, I pulled out 1 t, so no t, so I'm done. And now look what's left. t minus 4, and that's not a difference of squares. Because the t isn't squared anymore. So that's why it didn't work in the first place. Any questions about that? We're going to stop there for today. Oh, we got a couple more. Nah, we're not doing those. There's this one, I'll just point it out. That's a difference of squares. You could try them. You can write them down and try them if you want. That's a difference of squares. This one you have to common factor first because they're all divisible by 2. You can common factor first. And this one, ooh, that would be our first complex trinomial, but we're not going to do that today. So you can work on, from the worksheet that we've been working on, I think we already did question 2 actually, and 3, and 4. So you can look at question 5 and 6, or just question 5 to start for now.